Angles of measure. Today we're going to learn some new terminology, and we're going to graph our angles, and then we're going to convert between two different measurements, degrees and radians. So the first thing I want you to understand is the rotation of an angle. The angle in standard position means that it starts on the positive x-axis, and this would be our initial side. So this is where it starts, positive x-axis. Where it ends would be the terminal side, meaning that it's terminated, it's ended. Now, if the angle is rotating counterclockwise, as it is in this first example, that means that the angle is going to be positive. If the angle is rotating clockwise, then it's going to be a negative angle. And our angles are just going to be 0 degrees, 90 degrees, 180 degrees. This is 270 degrees, and then one full rotation is 360. So what that means is that when we're rotating in the negative direction, then this is now going to be negative 90 degrees, negative 180 degrees, negative 270 degrees, and one full rotation is negative 360 degrees. The first question, I actually have all these notes prepared for you just because it's really important that you see the proper angle, and it's just done more to scale. Draw an angle with a measure of 210 degrees in standard position. So when you see the standard position, that means that the initial side is along the positive x, and then because it's positive, it's rotating counterclockwise. As you can see, 210 is broken up into 180 degrees, which is taking us just to the negative x position, plus 30 degrees. Now that 30 degrees, we call it our reference angle. And we'll talk more about that later on, but it is a very important term. I might run out of power here soon. Draw an angle with the measure of negative 45 degrees. The angle is negative, so it's starting with its initial side on the positive x. It's rotating clockwise. Now it doesn't have to be exact. You don't need a protractor, but you do need to show me that you understand that negative 45 degrees is in quadrant 4. And it is between 0 and negative 90. Now we would say that our reference angle here is 45 degrees, not negative 45 degrees, positive 45 degrees. Reference angles are always positive. Draw an angle in standard position. So it says a springboard diving competition in a diver made 900 degree rotation before slicing into the water. Draw an angle in standard position that measures 900. So what you need to do is you need to show that 900 degrees is going to rotate multiple times. So you're starting in the initial spot, you're going all the way around once, that's your 360. When you go all the way around again, there's your 720. And then you're rotating the difference to get to 900, which in this case is 180 degrees. So you're not just showing the next type of problem is going to ask to find a coterminal angle. This is a lot simpler than it actually sounds. A coterminal angle, if you break up the word co and terminal, we want to look at an actual angle that on the terminal side. So if our original angle is 210, so it's going to be past 180 degrees into the third quadrant. There's the fourth, first, and second. What we're saying is that we want another angle that's going to share that exact same terminal side. So our first one is our regular 210. Then we're saying that we want another angle that's going to be positive. So all we have to do is take where we're starting from, 210, and add a full rotation of 360 degrees. Then we would be back in the exact same terminal side with a rotation of 570. Alternatively, to find a negative one, we have that original 270, sorry, it's getting messy here, 210. And if we want a negative coterminal angle, remember, negative just means that we're rotating the other way. So we're going to subtract 360. So the final angle will be 150, which if we had started at 0 and rotated 150 degrees in the clockwise direction, it would be identical to the 210. Here's another one. Find an angle with a positive and negative measure that is coterminal with negative 120. So negative 120 means we're rotating clockwise, negative 180 degrees. So negative 120 is going to be in the third quadrant. So to find a coterminal angle that's positive, we can just add 360. So it's like we're rotating the negative 120. We add 360 and we're back in the same spot, 240 degrees. Or we rotate that original negative 120 and then we subtract 360 and we're back in the original spot. I'm just looking at my work here. That should be a negative there, and that should be a negative there. That makes more sense. These are our coterminal angles. The last thing we're going to talk about is switching between radians and degrees. So radians is just another unit of measurement. It's like converting between kilometers and miles. There is a conversion rate. If you're changing between, let's see, what else? Gallons and liters. There are two measurements, but they're different. So therefore, we have to convert them back and forth. If we're converting from degrees to radians, we multiply by pi over 180 degrees. If we're converting from radians to degrees, it's just the reciprocal. Write 30 degrees in radians. So we have our degree. Here's 30 degrees. We multiply it by pi radians over 180 degrees. So the degrees cancel. We then are doing, that's the same as 30 over 1, so 30 times pi over 180. We can leave this as a fraction. We don't have to actually use the pi button on our calculator to get a simplified number. We like it actually in the fraction form. So 30 degrees is equivalent to pi over 6, which is really just a number, but we're going to leave it like in terms of pi. Write negative 5 pi over 3 in degrees. So we start with the negative 5 pi over 3. That's in radians. We multiply it by 180 degrees over pi radians, so we're canceling the radians. We cancel the pi's, and then we multiply negative 5 times 180 degrees over 3. And then we simplify it. So remember, when we're leaving something in radians, we should have a pi in our answer, and when we're in degrees, we should not have a pi in our answer. This is a breakdown of all the most common radians and degrees that you will see. Now, we talked earlier about the 30, 60, 90 triangle and the 45, 45, 90 triangle. So what this does is it actually uses those angles, 30 degrees, 45, 60. 30 degrees, meaning 180 minus 30, 45 degrees, and 60 degrees. So 180 minus 60 is 120, 180 minus 45 is 135, 180 minus 150. Remember I talked earlier about reference angles, and reference angles are always an acute angle, so meaning between 0 and 90 degrees, and it's measured from an x-axis. So here we have 180 degrees. When we add 30, meaning our reference angle, we get 210. We have 180 degrees. When we add 45, which is our reference angle, we get 225, and so on. The last concept we are going to talk about is how to find the arc length, which is the length of the arc on the circle. So it's bent a little bit. The symbols are S, which is arc length, the radius, so the length from the center to the edge of the circle, and the angle of rotation. The steering wheel on a monster truck has a radius of 11 inches. How far apart does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? We have a circle. The radius is 11, so R equals 11, and it's making a rotation of 4/5. 4/5 of a rotation, meaning a full rotation is 360 degrees. If we change that to radians, because arc length always has to be found in terms of radians, 360 degrees times pi over 180 is equal to 2 pi. So we want 4/5 of the rotation of 2 pi. That's how we get 8 pi over 5. Then we use our equation, S is equal to R times theta. We replace the R as 11 inches. We replace 8 pi over 5 as our rotation, and we get 55.3 inches. So that is the distance that it travels on the arc.